All right, buddy. Let's go over a little bit of chapter 2.1. All chapter 2 is on chemistry. Some of you might be wondering, well, why are we studying chemistry? Pay money to take class on biology. Biology is a study of life, but living things, we're subject to laws of chemistry and laws of physics. We're going to mainly focus on chemistry in this class for things outside the realm of biology. And one little example is of these ants in South America. And here you can see a picture of them. They live in these little areas that's called the Devil's Gardens, where pretty much the only vegetation you find are these Doroya trees. And somebody wanted to do an experiment. They had kind of a hypothesis that these ants might be maintaining the Devil's Gardens. So what they did is they took some plants that weren't the Doroya tree. They put them inside the Devil's Garden. Then they put some outside. And they had a couple different treatments. They had kind of like a control treatment where they just didn't do anything. And then they put like an insect barrier to make sure that, the ants couldn't get to the sapling. And then, they had a group that was within the Devil's Garden and then a group outside. They made sure that both all these Cedrela saplings either were unprotected or they had kind of the insect kind of a barrier around them. And they let this run, and then they noticed that, or what they would do is they would actually look at like an area of the leaves on these Cedrela saplings, and look at how much damage was done on them. So if you look at the graph at the bottom, the control group, the inside kind of unprotected group of Cedrela saplings, we're getting damaged quite a bit, whereas the ones that had that insect barrier around them, so the ants couldn't get on there, they weren't really damaged at all. And then when you compare that to the saplings outside of the Devil's Garden, you get pretty much the same results. And they concluded that these ants were causing the damage. And then, I'm going to go back here. Here they're squirting like an acid out of their abdomen called formic acid. So that's kind of where the chemistry piece comes in. They're using, certain chemicals to actually, break down the like the leaves on these plants. And when you destroy the leaves on a plant, they're not able to make energy, and then eventually they'll die. So that's how how the ants were maintaining the Devil's Gardens. So one of the I think it's important to know, first of all, that chemistry is the study or the science of matter. And matter is going to be defined as anything that takes up space. And if you take chemistry, they're going to say anything that takes up space and has mass. But that at a certain point, that becomes a circular definition, because the mass is an amount of matter, or a measurement of the amount of matter. So anyways, anything that's taking up space, we're going to consider matter. All life is made out of matter. So, that's definitely a link in chemistry. You're made out of matter. Whatever you're sitting on or standing on is made out of matter. So, and matter made up of elements. Elements are basically different types of matter. We define an element in chemistry as something that can't be broken down further by chemical means. It's hard to, if you don't really have a lot of experience, you may not understand or may not know what a chemical mean is. So a lot of times, we might take something, heat it up, and notice that it can be broken down further, or sometimes we might put it in like water, put it in acid, or do something to combine whatever we're trying to see if we can break it down further. Okay, so we don't, I would say you don't just know that it's one of the basic kind of building elements or basic building blocks of matter, and then we can take couple different types of elements and can combine them to make what's called a compound. So let me just take this example here. So sodium is an element. It's a metal. It's actually soft and gray. You can see here somebody's taken a knife and has cut it. Chlorine is another type of element, and it's a gas at room temperature. It's in the flask there. So sodium is very, very reactive. Chlorine is also very reactive. You would not want to ingest either sodium, like pure sodium. You wouldn't want to breathe in chlorine. It used to be a chemical weapon a long time ago. But these two can chemically combine together in a 1-to-1 ratio to make sodium chloride. And you can see how the properties have completely changed. Sodium, soft metal. Sodium chloride is what kind of a white crystal that's very brittle, and you can ingest it. People put it in their food. It doesn't really kill you instantly. It may kill you over time, but so you can see where we have completely different properties in sodium chloride versus the individual elements sodium and chlorine. Some of the elements that we have in our body are listed here. The major ones, so all these are considered essential, by the way, but the major ones that are about like 96% of your body mass, I like to call them nacho: nitrogen, carbon, hydrogen, and oxygen. I learned that from a student a long time ago. Even though oxygen, has the highest percentage in your body, mainly because it's a part of H2O, water. Carbon's found in a lot of things. Hydrogen also. Hydrogen's really tiny though, so it doesn't really take up a lot of mass. And nitrogen is found in many important chemicals or substances in your body. Things like proteins, DNA, RNA. And then in human body, we have a lot of calcium, right? Because our bones. Phosphorus is found, especially like your DNA and RNA. Potassium is found in lots of fluids. It's important for like nerve function. Same with sodium. Sulfur is found in your skin and hair, and so on. Then we have some trace elements that are found. It says they're like less than 0.01% of the mass. So the really, really small amounts, you'll probably find them in vitamins because they end up, they are important, but who knew that, your body had needed like a certain level of molybdenum. You knew that, iron's important, like in your blood, but other things, you may have never heard of these elements before, but they're there. And have it, they may have some certain function, and if they're missing, you may have some sort of negative effects. So, if we look here, this man looks like he's studying crops and maybe fertilizer. The corn on the right, it has nitrogen deficiency, and you can see it just isn't growing as tall as the corn on the left. All right, so that's kind of a big deal. But then we look here, we have iodine, the effects of iodine deficiency. This lady has what's called a goiter, an enlargement of the thyroid gland due to a lack of iodine. And iodine is one of those trace elements that's, found in like 0.01% of your mass. But there can be kind of big effects, if you don't get those little trace elements. So part of the reason why iodine is kind of put into like table salt. It's to help iodine deficiency. I think it also helps it from kind of doing some other things, but there you go. And also kind of other, we have other effects of elements. So some of them are toxic, and a long time ago, had all these lead mines, and people would, make lead, make pipes or like plumbing pipes out of lead. The symbol on the periodic table for lead is Pb, which stands for plumbum, which was like, I think, probably Latin for plumbing. So that's where the original, or that's where the symbol for lead comes from, but it ends up being really toxic. And it's fascinating how living things are actually able to kind of change, even if there are negative environments over time. So there's these weren't necessarily lead mines, but kind of like strains of like lead in this countryside. And I mean, that plant looks kind of wicked to me, but anyways, a lot of times you won't see any plants growing in kind of these areas, but over time the plants become very lead tolerant, all because of just that one element. And that's pretty much where I'll sum up section 2.1. Basically, just kind of intro to chemistry. We're interested in elements and compounds. They have different characteristics. And I will leave it at that.